Now let's solve a problem using two-way ANOVA. Our observations are productivities of different apple varieties in different regions of Russia. So we have 5 apple varieties named Jonathan, Ranet, Golden, Slava, and Antonovka. And we have 3 regions: Novgorod region, Saratov region, and Krasnodar region. And so the observations are 75 for Novgorod region, 75, 200, 100, 230, and 270. For Saratov region, 95, 300, 160, 250, and 320. And for Krasnodar region, it is 105, 310, 155, 255, and 310. So these are average kilograms per tree. So crops or productivities, average productivities of these apple varieties in these regions. And so let us say that we are asked to, so the question is there a significant difference between regions? So is there a significant difference significant difference in productivity between regions? So, as in previous problem, let us solve this assuming normal distribution of the response first. So, using the Fisher's test. So, we assume that observations are normally distributed. So, okay, to use two-way ANOVA, we are to find means for each row and each column of the table. So x dot 1 var is the mean for the first column. I have already calculated all these values, so just as I have limited space here, I won't write the formulas. I'll just give you the final values. So mean for the first column is 175. Mean for the second column is 225. Mean for the third column is 227. Mean for the first row is 91.67. Mean for the second row is 270. Mean for the third row is 138.33. Mean for the fourth row is 245, and mean for the fifth row is 300. So, these are marginal means for rows and for columns. Now I'm to find sum of squares, SS row, SS column, SS total, and SS residual. So SS column is the number of columns, 3, times sum of squared column means, so times 175 squared plus 225 squared. This is a simplified formula, not the general formula I gave you in my presentation, but this is a formula a little bit simplified for manual calculations, times number of columns times number of rows times we haven't I didn't give you the global mean, so x bar without any index is the mean value of the united sample. So if we add these 15 numbers and divide the sum by 15, we'll get 209. So this is a global sample mean. And so here we are to subtract number of columns times number of rows times squared global sample mean. So, and if we do so, the answer is 8680. Then SS row can be found in a similar manner. So number of rows, 5. Here squared row means starting from 91.67 to 300 minus 3 times 5 times 209 squared. So, and this will be 96084. So this is SS row. So then SS total, total sum of squares is sum of squared observations. So from 75 squared up to the last one, 310 squared minus 3 times 5 times 209 squared, and it is equal to 1,08010. So these are sum of squares that we find directly, and then the residual sum of squares, SS residual, that is SS total minus SS column minus SS row. And it equals 3,284. And so now we can find the test statistic. So if we are going to test a hypothesis that there is no significant difference between regions against an alternative that there is a significant difference. So our null hypothesis is that the region has no effect. The B factor, the region, the factor that has its levels by corresponding to the columns of our table. So we are testing the null hypothesis that the region has no effect, the B factor has no effect, against an alternative that it has some effect. And so the test statistic is FB. It is so number of columns minus 1, that is 3 minus 1, times SS column 8680 divided by SS residual 3246, and this is approximately 5.34. And now to test a hypothesis, we are to construct the acceptance and critical regions using the quantile of the Fisher distribution. And so we say that under null hypothesis, this FB follows Fisher distribution, and number of degrees of freedom in our case is 2 and 8. So 2 is for 3 minus 1, k minus 1, 3 minus 1 is 2, and here we have k minus 1 times L minus 1, so 3 minus 1 times 5 minus 1, 2 times 4, that is 8. So we have Fisher distribution with number of degrees of freedom 2 and 8, and the quantile let us use the standard alpha 0.05. The quantile is 4.46. And the test statistic, as we see, is 5.34. So we see that the test statistic is in critical region. So this means that the null hypothesis is rejected, and the null hypothesis was that the B factor, the region, has no effect. Unfortunately, I haven't got enough space to write down the hypothesis, but the null hypothesis is, one more time, that the region has no effect on apple productivity, and the alternative one, that it has some effect. And so the null hypothesis is rejected in favor of the alternative one. And so we assume that we accept the hypothesis that region has some effect on productivity. This means that, yes, we say that there is a significant difference in productivity between regions. So we accept this hypothesis we were asked to test. And so we say, yes, there is at 0.05 significance level. So our answer is yes, there is at 0.05 significance level. Now, let's solve the same example without this assumption on normality of our observations. So let's use Friedman's test. So we will test the same hypothesis, so that now I guess I'll have enough space to write it down. So the hypothesis that our terms are 0, this means that the region has no effect. And the alternative hypothesis is that at least one of these taus is non-zero, and this means that region has some effect. So the first step is ranking. So we rank observations, but within the rows. So in the first row, this is the earliest one, this is the second one, this is the third one. In the second row, the same. 1, 2, 3. Third row, 1, 2, 3. The fourth row, 1, 2, 3. And the last row, 1, 2, 3. So observations are ranked within the rows. If we are going to test a hypothesis on the B factor. So, okay, now we are to find mean ranks for each column. So R bar 1 is, we have only ones here, 1 plus 1 plus 1 plus 1 divided by 5. So 1 over 5, and here 1 plus 1 plus 1 plus 1 plus 1, that is 1. Then R bar 2, so mean rank for the second column, it is 1 over 5, 2 plus 2 plus 3 plus 2 plus 3, and it is 2.4. And R bar 3 is 1 over 5 times 3 plus 3 plus 2 plus 3 plus 2, and this is 2.6. So these are the mean ranks for the columns, And now we are to find the test statistic Q. Q is 12 times 5 divided by 5 is number of rows, divided by 3 times 3 plus 1. 3 is number of columns. And here we have, so the mean rank of the first column, 1, minus L plus 2 minus 3. L is 3, L plus 1 over 2, I'm sorry. L plus 1 over 2, so 3 plus 1 over 2. 3 plus 1 is 4, divided by 2 is 2. So 1 minus 2 squared plus 2.4 minus 2 squared plus 2.6 minus 2 squared. And so all this is 7.6. So this is the test statistic. As we know that under the null hypothesis, test statistic here follows chi-squared distribution with number of degrees of freedom L minus 1. L minus 1 is 2. 3 minus 1. So we are to use quantiles of the chi-square distribution with 2 degrees of freedom. Let's assume the same alpha as usual, 0.05. So here we have chi-squared quantile with 2 degrees of freedom of the level 0.95. And so here we have the acceptance region, and here the critical region. This quantile is 5.99 approximately. And the test statistic is 7.6. So we are in the critical region. The test statistic is in the critical region. This means that the null hypothesis is rejected in favor of the alternative one. So it's better to believe that the region has some effect. So the same result as in previous method. So answer is so the question was, is there a significant difference? And the answer is yes, there is at 0.05 significance level. So we see that this problem can be solved with 2 methods. By the way, one important thing is that we actually assume that the region has some effect, but if we look at what we see here, maybe it's better to say that not the region but the climate. As we see, maybe you don't know, Novgorod is situated in the northern part of Russia, and Saratov and Krasnodar are in the southern part of European Russia. So here we have more cold climate, and here we have warmer climate. And so we see that there is almost no difference between Saratov and Krasnodar, 2 regions that are situated in the same climate zone. And there is a great difference with Novgorod, which is in the other climate zone. And so maybe for this problem, after we see these results, after we see that there is almost no difference between Saratov and Krasnodar, maybe it's better to look from the other point of view on what is happening now and consider not just political subdivisions, but consider climate zones and consider these productivities of apples for different climate zones. And because now yes, we say that the region affects the productivity somehow, but if we consider two neighbor regions, for example, there will be no significant difference. So the point is not the region, but the climate. And so when you solve problems of this kind, you are to be very careful, because so the difficulty is not only to solve the problem, but also to formulate the question you are interested in, to formulate this question properly.